Hello guys, and welcome back. Today we're going to be starting 5.5, which is solving right triangles. And for a think slash warm up we know that we can find the third side of a triangle if we have 2 with the Pythagorean theorem. But how do you think we could find an angle of a triangle if we are given 2 sides? And it's no surprise we are working with trig, right? So let me just write a trig function down. We know that sine of some angle theta equals opposite over hypotenuse, but let's pretend we have both of those sides, right? Well, then the only thing that's missing is an angle, so theoretically we should be able to solve for it, and we can with something called inverses. So if we take the sine inverse of everything, we could find that angle. But without using a calculator, it's a little more in depth than that. So when given 2 sides of a triangle, we know a trig ratio, but the angle is missing. In this case, you would need to use an inverse of the trig function. These inverses are called arcsine, arccosine, and arctangent, or I just say sine inverse, cosine inverse, and tangent inverse. And for example, if sine x equals the square root of 3 over 2, that can be written as x equals arcsine of square root of 3 over 2. If we were to throw arcsine on this side, the arcsine and sine kind of cancel out. We'll see more of that later. And then this is how I'm going to prefer to write it. Sine inverse equals square root of 3 over 2. And if we have y equals sine of x, y equals cosine of x, and y equals tangent of x, then our inverse relations would simply be if we take sine inverse of both sides, then we're going to get rid of the sine here, and it's essentially just going to be x equals the sine inverse of y, and then it's the same thing if we do cosine inverse to both sides and tangent inverse to both sides. Or that should be x equals tangent of y. That's just the notation. It's not that more important. I think the example we go through will be more important. So solve each equation. So sine of x equals square root of 3 over 2. If we take sine inverse of both sides, of that side and of this side, then we get that x equals sine inverse of square root of 3 over 2. Now, without punching this into your calculator, what sine inverse is asking is whose angle is square root of 3 over 2 with sine? And, if we recall, I like to use my triangle for that one. Our 30, 60, 90, let's say that is 60, and that's 30 degrees. Then we know our hypotenuse is 2x, or you could just write it as 2. We know that the small side is 1 and that this side is square root of 3. So which sine gives us square root of 3 over 2? And it better be of 60 degrees, right? Opposite of 60, opposite over hypotenuse. So 60 degrees is our answer there. But we're not quite done, right? Because not only does it work for 60 degrees, but wouldn't it also work for an angle whose reference angle is 60 degrees? Right? If this reference angle is 60 degrees, then the sine of that also equals square root of 3 over 2. And so, if we have 180 degrees here and we take that 60 degrees away, the real angle that we're out is 120 degrees. Does that make sense? Because that's 180 degrees minus 60 degrees gives us 120 degrees. So 120 degrees works too. But now you might be thinking, well, what if we have this angle here or this angle here? Those ones are not included. And that's because our sine, we would need that to be a negative square root 3 over 2, right? Because if we make triangles, think of this triangle, we need the opposite, which is this side, and the hypotenuse is always positive. So whenever we're in quadrant 3 or 4, we have a negative y value, which is going to make, we would need a negative sign here for that to be true. So it's just 60 degrees and 120 degrees and anything that is coterminal with those two. But I would just write that answer and then say also any coterminal angles. Here is a similar one. Cosine of x equals negative square root 2 over 2. Negative, I remember that square root 2 over 2 kind of sounds like a 45, 45, 90. I'm going to think of my triangle where 45, 45, 90. And wasn't it that if this was 2, if the hypotenuse was 2, this was the square root of 2. And so that's cosine of 45 degrees, right? Because then adjacent would be square root 2 over 2, but it's negative. So negative, I'm trying to think what quadrants is cosine going to be negative in. And there's this little mnemonic where you just go around and say A, S, T, C, and that tells you where something is going to be positive. And A stands for all, S stands for sine, tangent, and cosine. I accidentally put another S by the sine. Fix that. So A, S, T, C, and that's where they're positive. So they're all positive in quadrant 1, and cosine is positive in this fourth quadrant, but it's not positive in quadrant 2 and 3. So that's where we're going to be looking. So we know that square root 2 over 2 is 45 degrees. So it will be the two reference angles who has 45 degrees. So that reference angle and that reference angle. And that'll be 180 degrees, the first one, minus 45, which is 135 degrees. And the second one is going to be 270 minus 45, which is going to be 235 degrees. Is that right? $225. I can't do mental math. 225 degrees. I was thinking too hard. 225 degrees because, yeah, minus 45, not 35. I had 35 in my head because I was looking at 135 degrees. So those would be your two answers. And now for this example 2, evaluate each expression. Assume that all angles are in quadrant 1, so that's nice. For this one, we have, I want to do the inside first. And now I'm saying whose angle has the trig ratio 6 over 11? Well, I don't know, but then if we look on the outside, we're saying what's the ratio of someone whose angle is 6 over 11? Well, doesn't that tell us? That should just be 6 over 11. And you can kind of think of it as like the tangent and the inverse tangent kind of cancel each other out. But that's like the thinking behind it, right? Tangent inverse of 6 over 11 is saying whose angle has ratio 6 over 11. And then the tangent saying, well, what's the ratio of that angle? So that's 6 over 11. That one's pretty easy. This one is going to be a little different. So if we're in quadrant 1, I'm just going to graph it right away. We have arcsine. So whose angle, sine inverse, arcsine, whose angle is 2 over 3? So I'm just going to make a triangle. I don't know if it's accurate yet, but I'm going to make a right triangle in quadrant 1 because we were told we're in quadrant 1. And if we take the sine of that angle, then that means opposite over hypotenuse, 2 over 3, is the ratio of that angle. So now I'm going to want the cosine, which is going to involve this adjacent angle that we don't have. So we need to do the Pythagorean theorem. 3 squared minus 2 squared. That's 9 minus 4, so the square root of 5. So this little angle here is the square root of 5. And then it wants the cosine of this angle right here. And the cosine is adjacent over hypotenuse. So that is going to be the square root of 5 is adjacent and the hypotenuse is 3. And that's all for today. Again, I'd really recommend memorizing this ASTC mnemonic. I think that's going to help you out a lot in these kind of problems. But yeah, in the next problems, we will get a little more into the title of the section, which is solving right triangles.